Now we're going to look a little bit at the gas law equations and the units that we use when we're doing these calculations. So we have two different versions of the gas law. The first one is the ideal gas law, PV equals nRT. The second is what we call the combined gas law, which is basically taking two copies of the ideal gas law and putting them together, because if I looked at P1V1 over M1T1, it's equal to R. So P2V2 over N2T2 is also equal to R, because R is a constant. These two things will be equal to each other. So we use these in a couple of different ways that we're going to talk about. But the first thing we want to look at is the value of R, which is 0.08206 liters atmospheres per mole Kelvin. And so this gives you a reminder of what units everything should be in when you're doing ideal gas law or gas law calculations. So notice that we have the volume has to be in liters, our pressure is going to be in atmospheres, the amount is going to be in moles, and the temperature is going to be in Kelvin. Okay? So use that information, the units of R, to help you remember what units you have to use in the gas law calculations. So when do we use the one on the left, the PV equals nRT, and when do we use the combined gas law? So when we have one set of conditions, so if it gives us a pressure, a volume, and a temperature, or moles, temperature, and a volume, anytime we have that, we're going to use the PV equals nRT. When we have two sets of conditions, any kind of factors that are an initial and a final, however it's labeled, if we have like a PVT initial and a PV final, we can plug it in and solve for that unknown. So we're going to use, whenever we have those two sets of conditions, okay, we're going to use the combined gas law. Something else to remember when we're dealing with the combined gas law is that if we have something as constant, for example, if temperature is constant, then we can actually cancel out the temperature on both sides, because if it's the same number, mathematically it will make no impact on the values of the unknown. So we can do that. Same thing if moles was constant, which is often the case, we can cancel out moles. If it were volume and temperature, we could cancel out both of those. So anytime we have something that does not change from the initial conditions to the final conditions, we can cancel it out and complete the calculation to solve for the unknown. If you find yourself with more than one unknown in either of these equations, you need to check back through the problem, because either you've missed something that you didn't include, or you have something that's constant in the combined gas law that you can actually cancel out.